Okay, so our first part of our unit was talked about unit rates, comparing speeds, that kind of thing, comparing prices. So comparing unit rates, this section. Then we have a section about scale diagrams, and then we also have a section about two-dimensional scales and things like that. Okay, Sarah can run 12 kilometers, or sorry, why am I reading 12? 10 kilometers in 1 hour, 10 minutes. Versus Jane can run 5 miles in 50 minutes. Okay, so there's our info. Who's faster? So we cannot compare this because it's not in the same unit. So we're going to look on our sheet. I gave everybody a conversion sheet. I probably don't have one up here. What do you have on your conversion sheet? Anything between kilometers and miles on there? Is there nothing?
What do you mean?
I don't have anything.
Oh,
no. No? Okay. Maybe I'll look this up, but I'm pretty sure. I think this is it. I think this is right. 1 mile is 1.6 kilometers. That seems to be in my head. We'll go 1.61. 1 mile equals 1.61. Did you know that?
No, they were saying that miles was bigger than kilometers. And they didn't believe me.
A mile, 1 mile is a further distance than 1 kilometer. A mile is bigger. Running 1 mile is more distance than running 1 kilometer. So for instance, if you go to Winkler, it'd probably be 42 kilometers. Going to Winkler is 26 miles. Okay. What are we doing? What do you want to do here? Do you want to change everything to miles or change everything to kilometers? It doesn't matter. We just got to pick. Kilometers. So let's change. 5 miles equals how many kilometers when 1 mile equals 1.61 kilometers? So we are going to change the 5 miles. So I'm going to do that by cross multiplying. And I don't have a need to divide by 1. So I got 8.05. Okay, now we have another problem. The other problem is this. 1 hour and 10 minutes. We can't use that in math. What do you want to do with that? Just change it to full out minutes. So 1 hour is how much in minutes already? 60, and then another 10. So we're going to write 70 minutes there. So you're going to have some kinds of times, so making sure that it's good. Actually, I should have maybe written this the other way. When you're doing a running race, what makes more sense to you? How many kilometers per minute or how many minutes per kilometer?
I think it's like, because my mom runs it, I think it's like
How many minutes?
per mile.
Per, yeah. So I'm going to flip this fraction around. Okay. So 70 minutes divided by 10 kilometers is how many minutes to run a kilometer? Okay, can you get me what I would call a unit rate? Okay, so you're going to be going, every kilometer takes you 7 minutes. Okay, versus we had 50 minutes to go 8.05 kilometers. So who is faster? Jane. She can run a kilometer in 6.2 minutes, which is faster than running a kilometer in 7 minutes. Okay, so something like that would be on your test where I'm trying to trick you by throwing kilometers and miles into a question, which are different. I'm going to throw in some 1 hours and then other things in minutes, and you have to understand to make sure that everything's in the same unit. Okay, a meat store, so the info, I have $7.99, 2.4 kg at one store, and the other info is $1.10 for 6.6 pounds. So that's just me picking out the info. So dollars, that's good. Kgs and pounds, not good. So again, you can pick, what do you want to do? We can do everything into kgs or we could do everything into pounds. Doesn't matter, as long as you're getting a comparison of the same thing. What do you have on your sheet? I think that one's on your sheet.
You have both of them.
I have both of them. 1 pound equals 2.2.
0.45 kg, or what?
0.45 kilograms.
Yeah,
That's what 1 pound.
so 1 pound.
0.45.
Yeah.
1 kilogram equals 2.2 pounds.
So that's on your formula sheet, so I don't care. What do we want to do here? Let's just make a decision. Are we going to go everything to kilograms or everything to pounds? Did you say something? Pounds? Pounds. Okay, we voted. Pounds. Okay, so 2.4 kg is how many pounds? And then I'm going to write, it doesn't matter what you want to use there. They both will work. I'll just go 1 kg equals 2.2 pounds. Okay, so 5.28 pounds. What makes more sense in real life? The price per pound or the pounds per dollar? Price per pound. So $7.99 for 5.28 pounds is how much price for 1 pound? Okay, so I'm getting a unit rate and we're getting everything in dollars per pound. Okay, good with our numbers. $1.51 per pound, and the other one's $1.68 per pound. So cheaper is, the answer would be A is cheaper. Okay, number 3. Fuel for a farmer is $1.58 per liter. His tractor is from the US and holds 125 gallons. How much will it cost the farmer to fill up if he's completely empty? So I have a conversion here. So 1 gallon is that many liters. Okay, so let's convert this. 125 gallons is going to be how many liters? So cross multiply, so times, you don't need to divide by 1. So that's how big the tank of gas is. So how much is it going to cost me to get that full? Okay, so let's go. $1.58 is for 1 liter. How much money for the 473 amount of liters? Okay, so I wanted to see how big the tank was in liters, not gallons, and then the money. So it's almost going to be $750 to fill up that tank. Okay, does it make sense, the ratios that I'm setting up? Okay, number 4. This is a distance and time graph. I'm going to kind of talk to you about some sections here. This is kind of a section 1, section 2, 3, 4, 5. So if I kind of put some points on where it's changing, maybe that will be helpful. Okay, indicate by circling on the graph which section is the person going the fastest. Which one am I looking at? How do I know something is fast versus slow on a graph? Steeper. I'm looking for the steepest part. So the steeper the line, it means the faster you're going. What do you think here? I would say just after the 1, like in this section. Anybody's agreeing with me? Like that would be the steepest part? Okay, so indicate by circling, so that's the fastest. What is happening over the 2 to 3 hour span? It's a flat line, so what does that mean? You're not moving, so we're stopped. We haven't gone any distance in that hour, so that means we've been stopped. Can you figure out the speed from 3 to 3.5 hours? So in that section, I want the rate. Okay, so you ready? This height is at 120, and that is at what? It's going up by 20s. 20, 40, 60, 80, 100, 120, 140. So this is what? 150. Okay, so we went from a 120 to a 150, which means we have traveled how far? 30. I wish it wasn't blurry. I could read it. Meters? I don't know. 30 somethings. 30 meters. We'll go. It's there. I just can't read it because it's blurry. 30 meters for how long? 30 minutes? Which means how much per 1 minute? 1 meter per minute is a rate. That's a unit rate. I also would have been good if you did this. 30 meters over a half hour equals 60 meters per hour. Would also be a unit rate. Okay? I'm not sure if some of you had worked ahead and done it that way as well. Okay? Each is good. All right. Josh, cupcakes. Ooh, this is a bad time to talk about cupcakes. It has a recipe, 3/4 cup sugar, brown sugar, 2 cups flour. And that recipe is going to make 12 cupcakes. Josh is having a party and he wants to make as many cupcakes as he can. He's limited to what he has in the cupboard with brown sugar. He only has 5 cups. So what's the very most amount of cupcakes he can make? Okay, so we have 3/4 cups would produce 12 cupcakes. We know that. Sorry, distracted. My husband just drove by on semi. I don't know why, I always hear his semi. 3/4 of a cup makes the 12 cupcakes. So if we were to have 5 cups, how many cupcakes? Okay, we all know 3/4, how to type that in, or you can just do with the 0.75. Do you see what you're timesing and dividing here? This would be your times. And then you're dividing. If you do the fraction, just make sure you go 3 in brackets divided by 4 brackets. So I got 80. Did anybody match that one? Okay. You know why I wanted to give you this question? Because I wanted to trick you. When you read word problems, that is, what do you call that? Just extra info that's just trying to throw you off. It's not anything that I need to solve this problem, but sometimes questions have that. They have extra info that you don't need. So be careful when you read problems. Sometimes that might happen. Okay, a computer chip is 12 millimeters wide and long. When it's drawn on paper, the designer draws it 9 centimeters long. Write a scale. Okay, so this is not good. We're in millimeters and centimeters. So what do you want to go to? Do you want to change this to a centimeter, or would you like to change this to a millimeter? I'm going to change this to millimeters. That'd be easier. Anybody know this one without looking at the paper? Do you know your measurement stuff? 1 centimeter? How much? 10. Okay, we write scales, diagram to real life. So on the diagram we had 90, but in real life it was 12. Which one of those should I turn into a 1? The 12. You take the smaller one. So if I cross multiply, what's 90 divided by 12? 7.5 to 1 is the scale. Okay, and when it's written in that way, it means the real life object is small, right? Diagram to real. Always, yeah.
How come there's a 1 under the 12?
Because you have to change either the 90 or the 12 to 1.
Oh, okay.
And the rule is the smaller one will go to a 1.
Okay.
Okay, a car is 15 feet long. On paper, it was drawn as 10 inches. Write a scale. Again, not in the same units. What do you want to do? Do you want to change feet to inches or inches to feet? What's easier to do? Feet to inches is easier. It doesn't, but that would be a decimal. It won't matter in the end, so you'll get to the same place. But okay, 1 foot. You know how long a foot is? How many inches are inside that? Oh, good, we knew that one. Okay, so I would times, which is 180. Okay, so my scale diagram to real. So on my diagram, I had 10 inches. In real life, I had 180 inches. So which of those should I turn into a 1? The 10 will turn into a 1. And then I would have 180 divided by 10. We could do that one in our head. 18. So my real life object is 18 times larger than the paper. Okay. A bedroom was drawn on a house plan, 3 inches by 5 inches. A scale of 1 to 45 was used. So what are the actual dimensions of the bedroom in feet? So every 1 on the diagram is actually 45 times larger in real life. So therefore, the 3 on the diagram would actually be how big in real life? Okay, 135 inches is what I got. Same thing we're going to do, the diagram to real. Every 1 on the diagram is 45 in real life. So having a 5 on the diagram is really 45 times bigger in real life. All right, now I need that actually in feet. So 135 inches is how many feet? When I know 1 foot is 12 inches. But you make sure you're lining stuff up. Feet, inches, they're lined up. Okay, and then repeat for the other one. Okay, so that's the actual dimension of the bedroom in real life. If you really wanted to impress me, you could have answered 18 feet 9 inches.
Would that give us bonus marks?
It would give me such a high impression of your math skills. Okay, that was okay as a question? Okay, a dog kennel that measures 2.53 by 2.88. It was drawn on a scale, on a paper. The scale was 1 to 36. What dimensions will be on the paper in centimeters? Are you going to be okay if I change everything to centimeters right away? Is that okay? Okay, I got to change everything to centimeters. Some of you might just know how to do this kind of fast without the ratio. That's all good. How do you know how many centimeters are in a meter? You know that one by memory. 100? 1 meter is 100 centimeters long. Okay, so that's how big the dog kennel is in real life. On the paper, we have a scale here. So diagram to the real life was 1 to 36. Okay, this is different than the other question because this time I'm telling you the real life. That's the real life, so I want to figure out how much I should draw on the diagram. Okay, so last time, right? Do you see the difference here? The last time I wanted the real life object, and on this time, on the ratio, I want what's the diagram part. Okay, so that's how big my diagram will be on my paper. Okay, an atom was drawn on a paper and it had a 6 centimeter diameter. Here's the scale. What's the actual in millimeters? So can we just go millimeters already? 6 centimeters. Let's just get it to millimeters already so that we're going to work with the same stuff. 1 centimeter is 10 millimeters. So now we know how long 6 centimeters is 60 millimeters. Okay, diagram to real life. It told me the diagram was 1:15 to 1. Okay, where are we putting the 60 and where are we putting the question mark? 60 is the diagram or the real part?
Diagram.
60 is the diagram. How much real is the question? So everything I go to, everything ends up with a cross multiply, right? So 60 divided by 115. Are you getting a 0.52? So it's a very, very small atom, right? That's why it was drawn bigger on the paper. Okay, a grain of wheat is measuring 6 millimeters long, 1.7 wide, drawn. Here's the scale. What will the dimensions be on the paper in centimeters? Are you okay if I convert after on this one? Or do you want to convert now? Doesn't matter. We can do either. Just now? Okay. 6 millimeters is how many centimeters? This is going to be a decimal. So both of those dimensions are decimals. Okay, diagram to real. Every 25 diagram is one real life. What are we solving for? A diagram or a real? We want to know a diagram if the real life is 0.6. Okay, once you've figured out where to place everything, everything at the end is always just a cross multiply. Okay, number 12, finding an appropriate scale. Okay, so our bedroom is 4 by 4.5 meters, and we want to fit it onto a piece of paper. Okay, so this is my bedroom, 4 meters by 4.5 meters. I want to end up getting it onto a paper in centimeters. So are you okay if I understand to times this by 100? That's the conversion. Can I just do a little shortcut instead of a cross multiply? Are you okay? 400 centimeters, 450 centimeters. We're needing to obviously reduce the size. Does it matter where I put the 20 and the 24? Yeah, it makes sense that I would put the long side of my bedroom on the long side of the paper. Okay, short side of the bedroom, I may as well line it up with the short side of the paper, right? Okay, can you divide those two numbers? And you can always do the big divided by the smaller one. Okay, so when I'm reducing something, I need to make sure I'm reducing it enough that it's inside my paper. So I have to pick something larger, the larger number, or even larger. Okay, if I pick 20, this side length will be exactly the length of my paper. Do you want that, or do you want to go even smaller so it fits on my paper? Smaller? Do you want to use a 25 then? Okay, so a 25 is what I'm using. How do you want to write the 1 and the 25?
What is diagram?
Every one on the diagram, we're going to use 25 in the real life. So that's the scale. Okay, so let's reduce by 25. How big are the sides going to be if I reduce them by 25? I'm trying to draw stuff in a bedroom. What do you all have? A desk, closet, a door. How do you draw doors in a picture? Okay. Laundry basket. So your bedroom, that's me drawing my bedroom on a piece of paper. So it would be 18 by 16, which fits nicely on that paper. Okay, we have a shape. Don't know the shape. It has a height of 3.4, and then the new height is 7.14. Let's go find the linear scale factor. So what are the dimensions? A height is a linear thing. So do you understand we're always doing new divided by original? We are always working like that. So the height increased 2.1 times larger. How much larger is the area going to become? What do? Square it. The area scale factor will be 4.41 times bigger. Okay, same question. I gave you a diameter and a new diameter. So what is the linear scale factor? The new divided by original. New divided by original. Do you understand that this number is going to be less than 1? Because my new object is smaller. So whatever you're getting, you're thinking less than 1. So that's a reduction. My object is reduced in size. So area scale factor would be the side, how much the sides are changing, but we're going to square it. So the area is going to be 0.49 times. It's going to be reduced. Okay, ready? Can you figure out what is the scale factor between the areas? This is the original and this is the new. So what's the scale factor between the areas that I've given you? The new area divided by the original area. So the area is 2.56 times greater. Okay? How am I going to get the linear scale factor now? I'm going the opposite of what the last question just did. Square root 2.56. So the side lengths are 1.6 times greater. So what is the new length? So I'm going to do 2.8 centimeters. I'm going to times it by 1.6. So that's the new length of my rectangle. Okay, but do you see how I had to go through what's the areas, what's the scale factor of those sides, and then I solved the problem. Okay, same question I gave you. Figure the same thing out. What's the area scale factor? What's the linear scale factor? What's the new radius? Can you break those down and see if you can get that one? It's the same process. What's the scale factor with the areas? So, by the way, on my calculator, I'm square rooting my answer button. So I don't have to round anything, I'm just kind of square rooting my answer button. It's all on my calculator. Did we have some self-awareness on that question that my shape was getting reduced? So my radius will be smaller in the end, right? Because my shape is going scale factor under 1, reduction, all those things I'm also paying attention to. Okay, almost the exact same question. I'll let you try it on your own. We need volume scale factor. That's the only difference, the volume scale factor. Then figure out the linear scale factor, then new height. Okay, volume. So changing your square root button to something else. Okay, always remembering new divided by original. We are doing an enlargement. Our shape is getting bigger. Did everybody still find your cubed root button? Anybody forget where, do you remember where your button was? Okay, how did that go? Did we find that we would have to cubed root that to get our linear, right? To go from a volume to a linear? Okay. Number 18. We have a radius and a new radius. Okay, so that means let's come up with the linear scale factor. If we have a radius and a new radius, let's figure out what the scale factor is. So I should see a reduction. So I should see something less than 1. Reduction scale factor. Okay, now get me the volume scale factor. What's the volume scale factor? So this time I'm going to cube it. Okay, last time we went from volume to linear, that's cube rooting. Now we're going the opposite way, so we're cubing. Okay, what is the new volume is your final question. So it's going to be something smaller. We're reducing this shape. Okay, see if you can do the last question. Break it down into the 3 parts again. I have been given volume. So I'm going to go volume scale factor. Everyone knows I'm really doing cubed root of answer, like I'm keeping these values into my calculator. So I've reduced, so what did 5 inches reduce to?